Good afternoon and welcome to our webinar, Desktop Virtualization Steps for Success. My name is Kevin Cook and I'm a Market Development Manager with Terakai Corporation. Today we will be presenting on the final piece of the virtualization desktop infrastructure puzzle, how to validate, monitor, and manage your end-to-end architecture. If you missed part 1 or part 2 in this series, please visit the Terakai website to watch streamed archived versions of those parts. Today I'm very pleased to introduce Matt Boyajian. Matt is an industry leader and virtualization expert with over 13 years experience designing, architecting, and optimizing desktop implementations. Matt will present on how the move to virtualized desktop infrastructure requires us to think and plan a bit differently to achieve success. Specifically in part 3, we will focus on the need to validate all computing layers that support the desktop virtualization architecture. We'll also discuss how to measure and proactively monitor utilization, as well as how to accurately manage and provide operational visibility into this next generation end-user computing environment. So without further delay, welcome Matt.
Good afternoon, ladies and gentlemen. My name is Matt Boyajian, Solutions Architect, and today we're going to be talking about part 3 of Steps for VDI Success. Bit of an aside, real quick. I have a tendency of speaking a little bit quickly. It's the New Yorker in me. I sincerely apologize. We'll be trying to dial it back just a little bit today to make sure that everybody gets on board with what we're trying to convey here. Number 2, I have to apologize in advance because this last portion of 10 Steps to VDI Success is going to be very math heavy. For all those who are immediately getting flashbacks to algebra and calculus, again, I'm sorry. The good news is that we're going to be showing you all the hard work that goes into this because, like anything else, there's a lot of shortcuts that you can use to eliminate the ability or the need for your engineering staff to have to go through advanced sigma calculations and all of those wonderful things. So with that, let's get started. And let's first talk about moving proof of concept into a pilot. Now, if you've gone through steps 1 and step 2, by this point, if you followed the steps in the guide, you may be ready to move your POC environment into a pilot phase. Now, when you're designing a pilot environment, you should make sure that all of your clients have the latest version of your optimized image and that you can run that image for at least 30 days. Now, we covered a lot about image optimization in step 2 of 10 Steps to VDI Success. I cannot understate the importance of image optimization within any particular environment. The reason that I kind of cling to that 30-day rule is that if you have a series of clients within your POC and you're steadily optimizing those images, the last version should be the one that you're validating against before you move into pilot phase. Because more than likely you can have 10, 20, or 30 different images that you've validated at any single point. Now, if you're looking at non-persistent link clones or anything else like that, then it's a little bit easier to implement these new images within your user environment, provided that you're using both a profile management service as well as a methodology to handle the software streaming service. Now, there's a couple of other things that have been introduced into the environment lately, introduced into the ecosystem of VDI, that we're going to be talking about at the end of the presentation. More importantly, the concept of user-installed applications. Now, we're going to be speaking very briefly on that and discuss how that changes the landscape a little bit and kind of gives you a little bit more choice when it comes to how to implement these streaming applications into your image, whether or not you should include them into the image at all, and helping to eliminate the number or at least detract from the number of images that you have out in your environment today. Now, you should also have an accurate sampling of your user base within your POC environment. This will ensure success when you are architecting the new environment that you will design. Now, what does this mean? This means that monitoring tools within a POC and a pilot environment are absolutely key. We cannot overlook these things. Now, a proper monitoring tool is going to give you insight into the 4 main areas of VDI that we need to really exploit. Number 1 is what all your users are doing. What are their machines doing? What are their metrics? What do their IOP tracks look like? What are they doing for CPU on the user and system side? What's their memory reservation? What's their memory utilization? Things of this nature. That's area number 1. Area number 2 is we also need insight to whatever hypervisor environment you happen to be running as well. So if you're ESX, if you're Hyper-V, if you're Citrix Hypervisor, you need something that's going to simultaneously give you access to both the areas. Because how are you to know whether or not the issues that your users are complaining about reside because of their own fault or because of the fact that your specific server happens to be overloaded? And in this particular case, just looking at a vSphere client or a Citrix server client to derive what the server is doing is not good enough. That is, unfortunately, not enough information for us to figure out whether or not the server has host ballooning problems or memory swap problems or is I/O limited, things of this nature. There's just not enough information there to get us to where we really need to be. Area 3 is going to be your storage controllers. You need insight to all of your storage controllers at any one particular time to find out where your hot zones are. Is one LUN overloaded? If we have 2 storage controllers, is one more heavily loaded than the other? How do we balance these things out? So again, we need insight into that area to figure that out as well. The 4th area is a bit confusing. So specifically what we're going to be talking about is the need for monitoring within the virtual switch environment of your hypervisor. Now, a lot of clients will come back to me and say, well, that's kind of redundant. I don't need that. If I have a sniffer, I can always plug a sniffer into my physical switch, and then I should be able to see everything that I really care about, and I'll just set my network engineers to work, and then I'll be good. The problem is that's not good enough, and here's why. If we have a tremendous amount of traffic between 2 virtual machines hosted on the same hypervisor, none of that information, none of that traffic, none of those packets are ever going to escape the clutches of the virtual switch inside your hypervisor. So that's information that you'll never be privy to unless you have a methodology for capturing that data. So in terms of green fields, what we need for the 4th area, we need the ability to set an aggregated sniffer inside the virtual switching environment of every single one of your hypervisors that are monitoring for VDI. Now, when we have all 4 of those areas combined, local client, hypervisor, storage controllers or LUNs, followed by virtual switch sniffing, now we have a complete picture of exactly what's going on within our VDI environment, and now we can also determine my accurate sampling of my user base. Next up, because we over-engineered the POC environment, it is important to remember that the old hardware may be able to be repurposed into the new pilot environment. So what does this mean? Again, as we talked about in step 2, designing a big bang VDI approach may not be the best one. And this is primarily because, excuse me for one moment, we have a nice little window telling me hello. And this is primarily because it's much more difficult to re-architect a large single server or single storage appliance than it is to re-architect a number of small modular servers. So if I have 16 servers setting up my VDI environment and we find that my server load is too high or too low, it's much easier to consolidate those than it would be to consolidate 2 single servers in a high availability environment. So small, modular, quickly able to adapt environments are really key here, and it makes moving from a POC to a pilot much, much simpler. So, best practices in regards to moving from POC into a pilot. Number 1, we need to gather data for the user CPU, system CPU, network, memory, video, and IOPS usage. And that second to last one is a bit confusing. How do we monitor video usage, and more importantly, why do we care? So there's a number of different ways to actually go about this. The easiest way to do it is through screen refreshes, or however many times the screen is being repainted by the operating system. Now, why is that important? Because whatever communications protocol we're using, that's what it's using to determine whether or not it has to transmit a change over the network to make that video usable by the user. So there's a number of different ways to use this, but the important thing to remember is that screen refresh rate, the screen redraw rate, has to be taken into account. And this is done for 2 reasons. Number 1, you need to identify the applications that have high video utilization, things like AutoCAD, things like video streaming services, et cetera, et cetera. And again, as we discussed in step 2, we also want to identify which applications may not be coded correctly for VDI. So if I have a very simple text-based chat program or a simple FTP program, that should not be chewing up a lot of video bandwidth. Because, again, everything in your hypervisor is rendering that video in CPU. That is a huge waste of resources, and we want to try to avoid that at all costs. Next up, collect data for both average user workdays and off hours to determine if there are any off-hours peaks that need to be designed against. Now, in non-persistent and persistent images, this is going to be handled in a very, very different way. Because if we have persistent images, then we're dealing with the standard way of doing things, which is I'm going to be using SMS or SCCM or Alteris to do my image updates for me. I'm going to be doing standard virus scans, mostly off hours. I'm going to be doing some kind of backup solution of possibly the user's profile or the system or anything else. The amount of utilization during off hours on persistent images is going to be amazingly larger than that of a non-persistent image. Now, if we have a non-persistent or a pooled image, that changes a lot because more than often than not, we're actually doing things in the image base. So if I have a update to virus scan, like a data update, a system update, a driver update, an engine update, those kind of things are going to be taken and put into the image, and then the image is going to get recomposed. When that happens, everyone just gets it, and then we're good to go. So we don't have to use any kind of push methodology from my virus manufacturer, or excuse me, Freudian slip, virus protection manufacturer or anything else like that to make sure it gets into the image. And by the same rights, any kind of security updates or bigger service packs or huge updates to Microsoft Office or things of that nature can automatically be put into the image so we don't have to use what precious little resources we have in that ESX or Citrix hypervisor to run those things. So off-hours peaks can be used towards doing things like migrating whatever machines are in line towards single servers and then powering off those extra servers. And that's going to save you a lot of money in terms of storage costs, in terms of power costs, cooling costs, things of this nature. And then you start to really realize where the long-term gains of VDI can be realized, which is I can start seeing other gains that are not necessarily immediately quantifiable. Next thing, collect both average and peak data for all data points that we wish to design against. Now this is really important because we're going to be coming back to it. But average data is very important. Average data during a working day is more important. But peak data is also necessary to figure out where our peaks and valleys generally are. And we're going to be using both of those pieces of information to calculate out exactly what we need for all the big 5 areas that we care about. So CPU, network, memory, video, and IOPS. So we're actually going to be showing you all the formulas that go into doing this, and they each have a whole bunch of pros and cons. There is no such thing as a one-size-fits-all formula. If you have anyone that tells you there's a one-size-fits-all formula, it's not correct. What you need to do is you need to create accurate sampling rates for all of your users, get all these pieces of data, run them in the formulas that are available to you, and then you need to do a double-blind test against those formulas based on user behavior patterns to determine which formula is the right to you. Some of these formulas are more expensive in terms of hardware allocation than others. Some of these are just not going to be really applicable to your environment because your user behavior between averages and peaks has such a huge, huge difference. So we want to make sure that delta is taken into account regardless of which formula that we use. Next, we need to architect this environment utilizing your preferred formulas for environment estimation. And we're going to be talking about all those. We're actually going to be talking about a couple others as well. Again, it's math heavy. I'm sorry about this. If you don't like it, that's why Terakai is here. They have engineers that are going to crunch all these numbers for you. More importantly, they have programs that will do this for us. So we don't have to constantly reinvent the wheel for our individual VDI solutions. Learn from partners who have learned from other clients. Learn from their mistakes. No one wants to be that company dead on the side of the road who tried VDI, who wasted millions of dollars, and who found that in one way or another it just did not work out well for them. Next up, perform a staged migration, augmenting that migration with new users. So what do I mean by that? I mean, don't do everything all at once. It's a false economy. Moving slow, moving in pockets of users, handling the users that adapt to change first is going to be your friend. Because again, even as we move from POC to pilot, we've addressed a lot of different problems, but there is no way that we have addressed all of them. We need to make sure that all the little nitty-gritty components all line up together, and we learn by doing. So make sure that you do a slow stage migration, and all those problems will bring themselves to light. So by the time you move to the last clients, your executives, your CEO, CIO, CTO, you're ensuring that their experience will be very smooth because you've already handled every mistake that could possibly be thrown at you. Next up, catalog the user's experience during migration. In other words, how is the user feeling? And I don't mean in that warm, fuzzy, happy California feeling kind of thing. I'm talking about what is the user's login time? How are their applications responding? How is their machine responding as a whole? How many applications responding do they have actually stuck in the queue? Or how many ANRs do they have? How many applications are not responding? What's their CPU queue depth looking like? What is their IOP queue depth looking like? Things of this nature. These are exceptionally important values that you have to collect metrics on. If at all possible, and again, this is going to depend on your monitoring tool, you also want to roll these numbers into a predictive analytics engine. So we want something that's going to take a look at these numbers, and whenever the deltas shift to a number that we're not used to seeing, so X amount of users all of a sudden are delivering a poor user experience, we want to know about that. And the reason that we want to know about that is because VDI is a shared resource engine. So if I have 10 users who are suddenly consuming a disproportionate amount of resources, being an order of magnitude or an exponential or anything else like that, then it's only a matter of time before those resources spread to other users' behavior patterns and usage habits, and eventually the resources are all used up. So we want to know when these kind of resource utilization problems occur so we can correct them before it spreads to other users. So basically, if 10 users have a problem, if 10 users are disproportionately consuming resources, and it's because of a security update or an Office update or a memory leak or anything else like that, I need to know about it before it reaches critical mass, before it gets to the point where my VDI users are calling up the help desk saying, VDI is slow to the point where I can't work. That is the absolute worst thing that could ever happen to your virtual desktop users, because you've given them this promise that when we take away your physical machine, we're going to give you something better. We have to guarantee that that product and process is always better. And the only way we can do that is by cataloging the user experience. All right, math lesson number 1. I promised it would be here. I promise we'll keep this as short as possible. So we're going to be talking about Sigma spec design formulas. There's 3 that I'm going to be talking about here. One of these is going to be modifiable by a certain percentage, and we're going to go over that in a little while. Now, these formulas are going to be applicable to all the 5 main areas that we talked about, but they're all going to be used in different ways. So the formulas don't necessarily change, but their application does. So in terms of VDI architecture planning, we need to use information from the assessment to make informed decisions when designing your VDI architecture. There's a number of design formulas that companies choose to work with when designing a proper architecture. And we're going to give you 3, and with 2 variants, quick example formulas that you can use for your own reference. Now, this specific formula is one that I never, ever advise you to use when designing VDI. So why am I showing it to you? Because this is your minimum spec. This is the absolute bare minimum that you need to function, and you should never be providing clients with this kind of level of overhead, because more often than not, if you ever hit a peak, then you're only designing for averages, and those averages are simply not going to be good enough to handle your client's peak data requirements. So the minimum design spec Sigma formula is meant to be the absolute minimum that your environment requires. It is highly recommended that you use either the good or best practices formulas, which we're going to be discussing, when designing your environment, as using this formula to design any resources will cause that resource to be overburdened in many situations. So what is this? This is a Sigma formula of X to the N, where X to the N is each client's average rating over the assessment period of working hours only. And that's really important because the average of working hours is going to give you their peak usage during the day. Y is the total number of clients. So basically what we're going to do is take all the clients and add up all their averages for whatever it is that the metric that we're calculating. We're going to add all that up and divide it by the total number of clients. This is a very simple formula. This is an average of averages. So this is going to tell you what your absolute bare minimum needs to be. Next up, Formula 2. I love Formula 2. This is a formula that I've used, including many of its variants, many, many times over. It's called the Good Design Spec Sigma formula. Now, this formula is also rather simple in nature. It simply follows the 80% rule, which I'm sure we've all heard before, where the normal generation of client traffic is considered 80% of the allotted traffic that it's designed for. In this particular instance, it allows for an additional 20% of overhead to be built into the system, which will provide most environments with a good amount of buffer space to function. Now, the problem with this particular formula is we have to verify that the output of this formula is going to be beyond that of what your users will ever request during normal work. So what do I mean by that? What I mean is that we have to incur that double-blind realization or benchmarking, if you will, where we're going to take the output of this formula and place it against the maximum peak averages of what your clients require. Now, how do we go about doing this? My favorite two ways are disseminating hour-by-hour reports, also known as boot storms, login storms, whatever storms you have, and then averaging those hours over a period during the assessment time period. So if I have a 30-day assessment going on, and during that assessment I'm breaking out my client usage behavior patterns hour by hour, at some point I have a boot storm where my peak average, let's just call it IOPS, peak average IOPS might be 13 peak average per client. That's the first double blind. So I want to plug all the information that I have into my formula here, and then the output of that formula should always be above whatever that max peak average during my storm is. Okay, that's area number one. Area number two is I like actually taking client behavior usage patterns, so good, fair, and poor VDI clients, and then I like segmenting out their behavior over the entire assessment period as a group. So in other words, what does this group use for peak averages? So, and then I'll take that particular point, and that's my second double-blind test. So if my formula starts pinging out that we have a 15 IOP design spec using the good design spec Sigma formula, I'm going to make sure that that 15 IOPS is more than my peak average boot storms hour by hour, as well as my good, fair, or whatever clients I'm designing for, max peak average utilization during the assessment period. Okay? What if it's not? What if that doesn't work? What if the formula in and of itself is not giving me the IOP overhead that I need to make this work? Do I simply fudge the numbers? No. There are three other variants of this formula that I have used. And so we simply call this one the 80% rule because we're multiplying it by 1.2. Now, if you find that the IOP number or whatever other number that you're planning for doesn't meet those two double-blind tests, and if it's too low, then we simply change this to the 70% rule. We multiply it by 1.3. If it's still too low, then we multiply it by 1.4. If it's still too low, then that's going to bring us to our next formula, which we're going to talk about in a moment. Now, what if the formula that we have used here generates too much overhead, that the 20% rule is just giving us so much overhead where the delta spec is out by about 30%. Then what do? Then we can use the 90% rule, which is multiply this by 1.1, and then you can verify that you're not overspending on your VDI hardware. Okay, with that, we're going to get into one more formula, and I promise this will be the last heavy math that you have to think about. This one's kind of complex, and I know you look at this thing and you're instantly reminded of college and how you hated math and how you hated multiple Sigma formulas, and that's exactly what this is. This is the best Sigma design formula. I don't wind up using this all the time, and the reason I don't is because sometimes this formula can be overkill. It depends on the variance of your client's max behavior patterns. And again, we'll talk about IOPS just to make things easier. If your average IOP utilization falls somewhere around the 5 area, and your max average IOP utilization falls somewhere around, let's call it 50, then this formula isn't going to work very well. It's just going to be a little bit too far out. Now, if the standard deviation between those two numbers is somewhere around the 300% mark or lower, then this formula will work great. But it also depends on what your client behavior usage patterns are. So the easy trick to this whole thing is that try every single formula you can and see which one works for you against your double-blind test while giving you the absolute lowest TCO. Now with that, let's talk about the last formula. Now this formula takes advantage of each client's usage over the assessment period and averages against the entire group of clients in the specific group. Then we will do the same thing with each client's average peak usage for the same amount of time and then average those two numbers together. This will allow us to design for a system that counts for both average and user peaks within the same data grouping and then giving you the ability to make sure that your environment can handle everything that you want. So in this formula, sigma of x to the n is each client's average rating over the assessment period during working hours only. Y is the total number of clients. We're going to add that to sigma z to the n, where Z to the N is each client's maximum IOP rating or CPU rating or whatever rating it is that you want to use over the assessment period during working hours only. And then we divide that by 2 to find out the average of the two numbers. Again, try all the formulas. And this is, of course, unless you want to leave it up to Terakai, in which case Terakai is going to let a handy-dandy little program do all this for you and then tell you exactly what it is that you need to buy and assign a next dollar figure to it. That's the easy way of doing things. And I promised you there's always a shortcut. That is the shortcut. So with that, let's talk about VDI architecture for network bandwidth. And this is where we're going to actually take all these formulas and put them back into practice. Now, in the case of network bandwidth, calculating the needs of the group is fairly easy. And this is the reason I chose this one first, because network is actually one of the simpler calculations that we can make. We will simply take the numbers from the baseline chart, plug them into the formula you choose, and the amount of bandwidth required is output. That's it. So we have some aggregate data here, and this is actually from a previous assessment that I did with a fictional client. We have all kinds of elements here, and what we really care about is the network I/O in terms of kilobytes per second. So we have the high observed is 10K, the observed average is 4.89, observed low is 2. And what we're going to do is we're going to take the minimum spec, and again, keep in mind, the peak average numbers are not in this chart. That was designed intentionally. We're expecting that you will use a proper assessment tool that's going to get all this information for you and then disseminate it for you as well. So our minimum spec is the number of clients times the average network I/O. That's real simple, real easy. The good spec is the number of clients times the average I/O times 1.2 to give us the 80% rule. And the best spec is the number of clients times the average times the number of clients times the observed high, and we're going to divide the whole thing by 2. So that's our best sigma spec. Very simple when you look at it nice here in black and white like this. Processor allocation. In this particular example, things get a little bit more complicated, but it's not terrible, because actually what we're going to do is we're just going to work with percentages. Because if we work with raw megahertz, things get a little bit flaky, and then we also don't have the ability to handle something called instructions per clock, or IPC. So percentages actually make this a lot easier for us. Now, if you examine this design baseline report, you're going to find that your monitoring tool will calculate the exact amount of cores that your specific group will require. Makes it easy for you. However, if you wish to do the calculations yourself, they're very simple to implement, either by percentage or CPU cycles, but I don't advise CPU cycles, again, because of the IPC factor. So for this example, we're going to take a look at CPU percentages and assume 3 gigahertz per core, just to keep the IPC nice and simple and across the entire flat line. Calculations output our number of cores required. Now this is great, because now we've actually put all this information into something tangible, something that we can use. So we can actually take the number of cores that we have, and the thing to remember about this particular formula is that you are always going to physically have more cores than the formula requires. Now, why is this? Because the number of cores that you have is never going to evenly divide towards the number of cores that you can actually get out of a system. So in other words, if I have 16 cores per box per server, and I require something along the lines of 28 cores, well, that's really not going to work for me. I'm still going to need a minimum of 2 servers. We also have to factor in the whole HA availability of things, where I don't want just my bare minimum of servers to go down. I want to make sure that I have some spare servers in regards to high availability environments. I want to make sure that I have something called a swing server, where if one of my servers goes down, I can automatically allocate all those people, all this traffic into another server, into another group of servers, because the worst thing that we want is not enough server bandwidth, because then VDI is just slow again. Our users are complaining. We should get this to the point where even if the single server goes down, the user group does not care. They should not notice, understand, or even have to realize what's going on. VDI should always just work for them. Now, in terms of the minimum spec, again, real simple. We're just going to add a couple of little new variables in there. Number of users divided by 100 times the average CPU percentage. That's minimum spec. Good spec, still the 80% rule. We're going to take the number of users divided by 100 divided by the average CPU used in terms of percentage times 1.2. Finally, the best spec, which again we can modify the good spec to make sure that we're okay with our double-blind checking, is the number of users divided by 100 divided by the average CPU used percentage plus the maximum CPU percentage divided by 2. We're not going to go over that formula again, I promise. So with that, let's talk about memory allocation. Now, there's a little typo in there. Unfortunately, I mentioned the name of a product that I used, and I apologize for that. We want to try to keep this as generic as possible. Now, your monitoring tool will also output the amount of memory that you will need, but this can also be calculated if you wish. Now, memory is different than CPU and IOPS. Now, what you're going to find is there's a tendency to want to scrimp on memory in VDI. We're going to say, well, our current clients have 2 gigs of allocation per VDI unit or per physical unit or whatever it is that we have. And I want to make sure that we do less than that. I want to do something along the lines of 50% or 30% or 20% or whatever. That is not going to work. And we discussed some of that in part 2 of the presentation, where we basically said that it's a false economy. And here's why. Whenever you're dealing with a hypervisor, the hypervisor's job is to make sure that it can always allocate as much memory for clients, even if that memory is over-allocated. So we're delivering more memory than we actually have physically available in our environment. Now, in order to make that happen, what the hypervisor does is, as soon as your memory utilization gets beyond 50%, the internal client to the local VM is going to tell the system that it's going to fool Windows into thinking you're out of memory, start paging to disk. So all that memory that you think you're saving, all that money that you think you're saving, is instead going to manifest itself towards IOP utilization. IOPS are expensive. So when in doubt, give clients more memory. This is also really important in regards to tiering. You need to tier your user bases because different clients have different memory needs. You need your assessment and monitoring tools to ferret out that information for you. So that way you're not relying on user complaints to adjust their memory. You're relying on user behavior to adjust their memory. So, just like before, we have 3 good use cases, and we can modify the good spec towards anything we want to do. Minimum spec is the number of clients times the average memory. Good spec is the number of clients times the average memory times 1.2. And the best spec is the number of clients times the average memory times the number of clients times the observed high divided by 2. Again, leave Terakai to the math. They're really good at it. They're going to make sure all this gets done for you. Storage architecture. We're really near the end of this portion, I promise, and then no more math. It'll be just best practice scenarios. So your monitoring tool will also capture IOPS per pool. You can also derive your own numbers if you choose. And again, just like with before, just like with memory, IOPS is actually fairly easy to calculate. But just like with memory, IOPS is a very scary place to be. We have to make sure that our images are optimized as much as possible because IOPS are just incredibly expensive. So we want to make sure that we have enough overhead so that all our clients can be readily available with whatever IOP requirements they have. But at the same token, overbuilding the environment is just a waste of dollars. So here the minimum spec is the number of clients times the average IOPS. The good spec, again, we can modify this to suit our needs against our double-blind numbers. Number of clients times the average IOPS times 1.2. And then finally, the best spec is the number of clients times the average times the number of clients times the observed high divided by 2. That's it. I promise. All right, so we're done with the math. I'm sure there's a couple people cheering out there if they weren't on mute. Let's talk about capacity versus IOPS. And this is, again, one of those lessons learned by the wayside of corporations or customers that have failed before. It is important to note that in some cases, IOPS may heavily outweigh capacity in your environment. This is especially prevalent when we talk about spinning disks. Why is this? Because when it comes to rotational media, the amount of IOPS served out by rotational media has been superseded by how many bits we can stuff on a platter. Or in other words, the amount of speed we get out of a hard drive has been kind of overcome by the amount of capacity that the hard drive can deliver. Now, it doesn't really matter which hard drive technology we're talking about. If we're talking about 7200 RPM with a SATA or a SAS, if we're talking about 10K FC, if we're talking about 15K, it doesn't really matter. One way or another, as soon as you get beyond the 400 gig space, you're going to have more capacity than IOPS, and that's a big problem. So if this is the case, you have to remember the following best practice. There is no such thing as wasted storage. Now, if there's any storage folks on the phone, I apologize for giving you a coronary embolism, but there is no such thing as wasted storage. Resist the temptation to take your VDI storage and allocate it towards other things. Because what's going to happen is, even though that storage isn't being used, the IOPS always are. And we spoke before in session 1 and session 2 about QoS, guaranteeing QoS. Now, if you have a frame that's capable of delivering 10,000 IOPS, and you know your client requirements are somewhere around 8,000 IOPS, and you need to guarantee that QoS with a monitoring tool that says my clients are now using 7,000 IOPS, if we stick something else in there, I now no longer know how many IOPS I have left over, how many IOPS my storage frame can deliver, or how many IOPS I'm over binding my storage frame by. So again, resist the temptation to stick other things on there. There's no such thing as wasted storage. Resist the urge to split VDI storage that is unallocated. So a lot of folks might say, well, I've got all these LUNs. What's going to stop me from taking all my VDI users and putting them on one group of LUNs, splitting the LUNs out, and then giving it to another application? Well, that's the same thing. You haven't really solved anything there because it doesn't matter how you divvy up your LUNs. You can't squeeze more blood from a storage stone. The amount of IOPS that the controller can deliver, that's just it. So obviously you want to follow best practices and make sure that your LUNs are split over as many drives as you can, but you can't get more IOPS from that, and you don't want to put more application or more load on something just because you did some funny math against your LUNs. It's not going to work. You can always have more capacity, but without the IOPS to serve it, it's wasted for VDI. So if I've got a storage pool that's got 4 terabytes worth of storage, but only 5,000 IOPS, and my users are calling for 3 terabytes but 10,000 IOPS, then I can't use that. That does me absolutely no good. Storage is the slowest subsystem of any component within a computing system, meaning that your hard drives in your de facto desktop that you have are the slowest thing that are running anything. That's why anytime that anybody installs an SSD into their computer, the first thing is, wow, my computer is so much faster. The computer is not faster. It's exactly the same speed it was running at before. The only difference is that you took the slowest area of the system and you basically made it twice as fast. So the machine might feel faster, but it's really not. So this is, again, where IOPS is so important. Tiered storage can suit multiple need groups well. And this gets us back to the whole monitoring tool. We want to identify what users are Tier 1, Tier 2, and Tier 3. And then we want to put them across different forms of storage. Why? Because it's more cost effective. So if I have a Tier 3 user, a business user, and their peak IOPS is somewhere around 7 and their average is 5, and I can stick them on 7,200 RPM SATA disks with a nice big cache front end, then do that. It's cheaper. But if I have some power users and they constantly require 15 or 20 or 30 or 50 IOPS, then you're going to have to start looking at different methodologies of suiting those users. Putting everybody on SSDs is cost prohibitive. Just the same way that putting everybody on 7,200 RPM SATA is going to choke out some users because everyone's going to be grabbing for IOPS that might not necessarily be there. Next, storage can always be repurposed if needs grow. Storage is one of those things that, a lot like CPU requirements, even more so, that a company can never get enough of. So in the event that you find that your current storage platform is not meeting your needs, repurpose it. Use it in something else. Put it in a different tiered storage and then buy a new storage frame, because your storage group is never going to complain if you give them too much storage, because there's really no such thing nowadays. All right. Let's talk about RAID levels. Now, I know we're getting really nitty-gritty here, but again, this is the kind of important stuff that we need to worry about when we're designing a VDI architecture. Even this matters. It is important to note that just because the number of platters can deliver a certain number of IOPS does not mean that the RAID group does not carry a certain amount of overhead. So we all know that when we're factoring out IOPS from a per platter perspective, then 10 KFC can give us about 100. 15 KFC can give us about 150. So logically, if I have 10 drives of 15 KFC, then I should have 1,500 IOPS, right? Wrong. It depends on the RAID level, because no one today is going to just take a bunch of FC drives, chain them all together, and say, okay, we're just going to run as something called a JBOD, or just a bunch of disks. No one does that. Why? Because as soon as a single drive fails, your entire array is shot. So we need some sort of protection overhead to guarantee that this doesn't happen. Now, there is a ton of different ways to do this, and different vendors actually have different RAID methods and different writing patterns, all kinds of stuff. Like, we know that there's all kinds of different formats that we can use, and you know, each vendor has their own trade-offs. And again, you should be asking your storage vendor, if I have X amount of platters in your standard RAID group, how much does that deliver me for IOPS? And they can tell you that very, very easily. Now, in terms of what RAID you should be using if you're building your own, You A, need to plan for the type of RAID you're using. B, you need to allocate the IOPS based on the total pool, respective of RAID type. And now let's talk about the different kinds. RAID 10's the fastest. You can't do any better than RAID 10, but will only deliver 50% of IOPS per platter. Why is that? Because RAID 10 is something called a stripe of mirrors. In other words, we have, let's call it 20 drives. And we're going to use 10 of those drives for simultaneous data transfer, and then the other 10 are going to be copies of the first 10. So if I have 20 drives, how many IOPS can I deliver with RAID 10? Well, the answer is 10 times whatever you have. If you have 15 KFCs, you've only got 1,500 IOPS. You don't have twice that, and you never will. RAID 0, 1, 5, 6, and 10 all deliver varying degrees of IOPS efficiency per platter. Proprietary RAID types must be taken into account with your storage provider. Make sure they know the total number of IOPS that need to be served. As long as they have that pieces of information, they can plan ahead. One other piece of information that I can really offer you that's going to help: do not count a caching controller as part of an entire IOPS amount served. And storage vendors are going to try to tell you, well, you know, we've got 5,000 IOPS available in terms of spinning platters, but we've got this cache module, and this cache module can do 50,000 IOPS. Now, does that mean that you have a 50,000 IOP device? No. Does it mean that you're limited to the amount of IOPS that the spinning disk actually can serve out? Sometimes. It depends on how the cache mechanism works. It depends on how inefficient it is. It depends on if it does read or write caching, how it's split. There's a number of different factors that go in there. Caching is always going to help you, but it should not be your primary dependence on what kind of IOPS you're getting out of a storage device. Now let's talk about some cool stuff. Let's talk about acceleration and deduplication. Now, many new technologies now exist that allow you to accelerate, cache, deduplicate storage technologies, which is great. Now, you must be aware that while these technologies speed disk availability, they're still bound by the number of IOPS that the platters can deliver. So in the end, your lowest common denominator always has to be raw platter IOPS. It's really nice that we can make all these technologies faster, but again, we cannot depend on them all the time. Now, these technologies can dramatically improve efficiency, and efficiency can be calculated by measuring the total IOPS of the group via your monitoring tool, then at your storage controller. You divide the total number of IOPS from the IOPS storage, will output the efficiency percentage. Now, what does that mean in plain English? Your clients are requesting X amount of IOPS, and your storage controller is delivering Y. And each storage controller has an FA and a BA, a front end and a back end. What you need to do is you need to plug into the back end of the controller. What are my actual platters delivering in terms of IOPS? Those are the numbers that we're going to be calculating, because that's going to tell us how efficient our caching engine is. Now, does that mean you can rely a little bit more heavily on the caching engine if you know how efficient it is in your environment? Yes, but again, be very, very careful of that, because as soon as you overstress a storage device, at some point, if anything fails, you're bound to lose all your VDI clients. So again, love the technology, love the speed, but never, ever rely on it. Whoop. Excuse me. Got some kind of strange window popping up. Apologize, ladies and gentlemen, but unfortunately, we appeared to have a window that randomly popped up on me. So we're going to just jump back right in here. Let's see. There we are. Calculating disk needs. Now, once you've acquired all your IOPS numbers that you need to define your architecture, you can report these numbers to your storage provider to have them design the best and most cost-effective design for you. There are many variables involved besides IOPS and capacity. I know that I've been beating the IOPS horse to death for the last, well, 40 minutes really. But it's not the only thing you have to worry about. Your storage vendors are going to tell you exactly what are the parameters that you need to know. And again, depending on your vendor, they have different variables, because they all use different technologies that correspond in different ways. Utilize the methods that fit the best using both your company's core knowledge coupled with best practice. And of course, use your VARs, use Terakai. They have knowledge and they have tremendous amounts of experience in this area. Use what you can. Now, if you cannot measure the QoS in a shared storage space for VDI, then that storage must be segregated in order to maintain a good VDI experience. This is also a reoccurring theme that I keep talking about. So again, this gets back to don't share your storage unless you can guarantee that it pushes stuff out. Now, there are new storage platforms that skirt this rule. So a lot of the big box vendors that have actually been pushing storage for the last couple of years, the new technologies that they have actually allow you to carve out certain amount of IOPS per client, per group, or anything else. And those will allow you to do QoS per group. So you can actually say, well, I have X amount of IOPS that I need to serve out for Y application, and I have 5 different groups that I'm going to have in this storage platform. I can use QoS monitoring to guarantee those IOPS. Yes, you can. Be very careful with this and make sure that you have full-time people available to evaluate just that. Because as soon as QoS goes downhill, so does your VDI performance. All right, step 8, finally. Step 7 was painful, wasn't it? Moving from pilot to production, modular design versus Big Bang. And this is, again, a good set of lessons learned that we've pulled. Once you've stabilized your images and determined the subsets of users that will use them, it may be time to move towards production from pilot and out. This will ultimately depend on whether or not your business finds the TCO of VDI palatable. That particular number is going to depend greatly on what kind of methodology you decide to employ. Persistent VDI is a tough pill to swallow. Non-persistent VDI is much, much easier going down, but then we know we have the whole profile, and then we also have the applications problem that we have to deal with. If this is the case, that you actually find VDI palatable, then you need to decide whether or not to design the system in a modular fashion or conduct a Big Bang. Now, you might be saying, well, wait a second, Matt, you just said that there's no way you should ever consider a Big Bang. Well, again, if you have the ability to guarantee QoS, it is possible. You just have to be absolutely sure that this is what you need to do because it's much more difficult to change after the fact. Now, it may be more cost-effective to perform a Big Bang rollout. However, there's a few points of caution. Once the environment has been designed, it cannot be undesigned. Vendors who are selling you $3 million cabinets usually don't have great return policies. Number 2, adding users past the design specification invites bottlenecks and risks the health of the group. Don't ever go beyond your max numbers. 3, adding storage, hosts, or networking in the future may become troublesome or expensive because generally when I have one large appliance or one large device that's designed to do things, adding a second one's fine, but that's really expensive and you need 100% more bandwidth. Well, more often than not, you don't. So you need 10 or 20 or 30%, and you're going to have to find something that works between the two devices, and they typically won't have the same design parameters or the same monitoring tools. Even if you stay with the same vendor, things get a little bit tricky there. This type of rollout, however, can be the least time intensive. Why? Because we're deploying less hardware. So again, it's kind of a tricky balance to decide what works best for your company. But again, modular has a lot of other attractive options to it aside from the time savings. Modular designs may seem more attractive in some cases, but they have some caveats as well. Design specifications for specific hardware can change over time, leading to mixed mode deployments. So we started buying these one group of servers, and we're deploying VDI on this one group of servers for a while. And then something happened where the design spec changed. There's a new processor in there, they switched vendors of something, and now I can't do seamless HA or seamless swapping or vMotion or anything like that between the two boxes. That's a problem. So you're going to want to consolidate on a hardware group that has a really long-term platform for you. Getting in early when a platform is released is also a nice thing to do. Older and newer hardware may not interoperate, and this is true for not just processors, but RAID controllers and network controllers and all this other crazy stuff. Again, this is where Terakai comes in. Use your VARs, use your vendors, use your ISVs to make sure that this kind of stuff is things you don't have to worry about because, again, they've been there before. Some VMware hosts may not perform failover functions if the hardware differs substantially, and that's, again, something we mentioned a couple times before. Now, we've actually worked with many, many, many customers migrating in terms of VDI. This is a handful of things that I've come up with, and these were all learned at separate customer accounts, actually. And these cannot be overlooked. So again, if you have to print out one page and tack it to your cube or tack it to your wall as the 10 commandments, if you will, of VDI, this is it. Number 1, plan carefully. Many organizations have abandoned VDI and lost money due to lack of planning when architecting VDI solutions. Having a trusted partner to guide you will help. Learn from their experience. And this is, again, another Terakai plug. Number 2, monitoring and assessing. If you notice, I didn't say or, I said and, are key components that should never be overlooked. I have some clients that say, well, I did an assessment, why do I need monitoring? Or I did monitoring, why do I need an assessment? The two are intrinsically linked. You can't do monitoring and not having an assessment, because then the amount of manpower you're going to spend on fixing everything with a monitoring solution is it's insurmountable. Number two, if you monitor your users, if you assess your users, you need to monitor them, because the data points, the images, and everything that you're doing is going to change. Nothing ever remains static. Just doing an assessment and then doing VDI without monitoring is like throwing a dart blind. You kind of know where the target is, but you're not really going to be guaranteed to hit it. Number three, never, ever underestimate the value of a tuned operating system. And again, this is one of those horses that I'm beating to death, but again, it's one of those things, that's free resources right there. The more we tune it, the more we get, the more our money goes. Buying too much of a resource is wasteful, but buying too little can be catastrophic. So which side do you err on? Err on the side of wasteful, but to the point of making sure that all your formulas match and making sure that your overhead isn't ridiculous. Again, use Terakai. They've been through this. They're not going to make you overbuy solutions. They're going to make solutions that work for you and work for you for now and the future. VDI is going to put, and this is a very, very interesting thing, because we're not talking about technology here. Here we're talking about psychology, and we're talking about organizational structure. VDI will put the burden of work across multiple operating groups. It may be worthwhile to create a new group to manage it. Why? Because within organizations, especially large organizations, we have these things called silos, where the storage group does their thing, the desktop group does their thing, the server group does their thing, and the network group does their thing. In the event that there's any contention between two groups, there's a lot of finger pointing, and eventually the problem may or may not get figured out. With VDI, all these groups have to interoperate seamlessly. There can never, ever be any finger pointing. You generally need to get buy-in from a very high managerial level and create either a group or a virtual group to oversee the whole thing. So what do I mean by that? Handpicking folks from every single group and putting them into one group called VDI, that's fine, but we don't have the resources for that nowadays. So what might be a good idea is taking the key members from each group and forming a group that they can all work together with. So one person from networking, one person from storage, one person to desktop, that's the VDI group, plus server and whoever else we need. These people are designed to work together, to supersede the boundaries that are normally incurred by having standard groups, and they can work above and beyond what you would normally cause roadblocks with. Now, VDI provides some cost savings in certain places. Its true value lies in providing your business units new ways of performing work, and they're going to find them. They're going to find all kinds of new ways that you have not thought of before. They're going to come up with new and interesting use cases. As long as you're aware of the fact that the business units are providing more value with the solution, this is your pitch to management. It's not in all cases that VDI is going to be the cheapest solution. In some cases it might be, but in others it won't. Cost alone is not a reason to run VDI. Function is the reason that we run VDI. Being able to work from home, being able to support clients that wouldn't normally be able to get into the office, operating during a snowstorm or in storm conditions or in power outages, any kind of things of these nature are very, very important. And now we can actually harness them appropriately. Your business units will continue to find new, and I already know I said this, new and exciting ways to utilize VDI that you have not captured. Learn to embrace this and use it as a way of promoting IT within your organization. All right, we only got 2 slides left, and then we're done. Everything's good. So number 1, in terms of step 9, monitoring, significance of dashboards. Now, we've talked about monitoring a lot. Dashboarding is one of those things that management always loves to see. Why? Because they like graphs, they like charts, they like things of this nature. Monitoring is not just good for management just to get them off your back. It's good to make sure that you have a good, high-level view of everything at once. You need to choose a solution that has dashboards that offer insight into users' habits, troubleshooting tools, image tuning tools, preparation for future operating systems, as well as application assessment. Every single one of these things needs to be counted and accounted for when you're actually going into a monitoring solution for VDI. Thinking that you can run without this, again, just like memory, is a false economy. Eventually, you're going to come across a problem that you cannot solve. Not without a tool that gives you insight into all the areas. The standard tools do not apply here. They do not work well enough. And I've had some engineers that say, well, I could just use perfmock for this, and I could use the vSphere client for this, and I could use my storage tools for this, and I can use my network guys for everything else. That's 4 separate environments. You shouldn't have to manage that. Not only that, getting them all together at once is very difficult. Making sure you can export data across those groups is almost impossible. You need something to cross-correlate all those functions for you. Finally, profile management. And we get some nice animated pictures. Profile management ties everything together to realize the true power of non-persistent linked clones. And there's a lot of vendors that do this stuff out there. Microsoft does it with roaming user profiles, and I know I just made 10 people cringe and cry. I'm sorry. Res does this, AppSense does this, Liquidware Labs does this. There's a lot of solutions out there. Pick the one that works best for you. Now, it allows you to do the following things. You can migrate user settings, you can migrate machine settings, you can migrate application settings, you can migrate user-defined data. And this is a big one because that's your company's IP. This is a huge impact in disaster recovery routines because just standard VDI does not allow you to capture all the IP that's stored within your user systems. But a profile management solution does. And that's, again, something that your management, your environment is really going to want to hear, because that's important nowadays. Disaster recovery plans are pretty much the norm, and with the weather that we've all been seeing over the last year, earthquakes, volcanoes, hurricanes, tornadoes, again, we have to have proper DR plans. Profile management needs to be a part of that, because we've always accounted for data that's present within our servers. But the reality is that balance of power in terms of data is shifting. You need to account for that and embrace it while you can. And finally, if you have a profile management solution that can do it, you can also migrate to new platforms seamlessly. And this comes in the way of something called V1 to V2, and when Windows 8 comes out, V3 migration. So I want the ability to not just migrate to Windows XP. I want to be able to jump from any operating system that I can. I want to go from XP to 2K, to 2K3 to 2K8, to Vista to 7 to 8, all within one day. I could even have 5 of them open at any one time if I wanted to. This is a very important hallmark feature. Look for a profile management solution that can deliver this kind of thing. And with that, ladies and gentlemen, thank you so much for your time. I sincerely appreciate it. I hope that you learned at least something from this, and if you need anything whatsoever, please don't hesitate to contact me, or more importantly, contact Terakai. Thank you.
Thank you so much, Matt. So let's jump right in here. We got a question about your math, Matt. So earlier on in the presentation, you presented a best formula. And the question is, aren't you missing an addition or plus operator between the two amounts that you then divide by 2?
I'm not sure. Let's find out. So I'm going to go back into my presentation, and we'll take a look right now. Hang on a sec. Let me show my screen. No, it's in there in the master formula. Hang on one sec. Let me share this out for you guys. There we go. Plus operator. So the sigma takes care of all the manual additions for us, and then the plus operator is between the two. If there's any error in my formula beyond that, I sincerely apologize for it. But again, this is why we have software, is that software does all this math for us.
So it's I guess, yes, it's in the master, but not in the examples, I guess was the comment.
Okay. Yes, that was correct. My apologies on that.
So thank you, Brian. Thank you. Keeping Matt honest here. Another question we have is actually from Eric, and Eric says that his organization has started down the VDI path, but they do have some concerns about how their infrastructure will scale. Is there a method for evaluating what's going on now so that they can start to make changes before they go down the wrong path?
Yes, predictive analytics. And I keep saying it over and over and over again. Predictive analytics is really key when it comes to VDI. In terms of short-term scale and medium-term scale, predictive analytics is going to help you. But you need something else if you're going to handle long-term scale. Because predictive analytics is more of a reactive approach. It's not going to tell you long-term. You need trending. So, again, your assessment tool is going to do some trending, but your monitoring tool is really going to do long-term trending. So what you need to do is you need to establish assessment baselines, pilot baselines, and then continuously monitor all those things and see how the percentages are being affected over time. And then utilizing those trending documents, you can say, okay, we're here now. We're going to be here in about 6 months. So monitoring tools are actually for a lot more than just ongoing predictive analytics and monitoring. They're going to tell you what you need in the future as well.
Excellent. Here's another question, Matt, specifically about profile management and applications. How should we handle user and departmental installed applications?
That's definitely one of the most loaded questions I've heard today. This was one of the things that I wanted to talk about at the end of the presentation. I'm actually glad somebody asked. The environment that we're in within VDI is radically changing every single day. There are new methodologies for what we refer to as UIA and DIA, user-installed applications and departmental installed applications. Now, what we see this as being in the next 6 months, because again, these technologies are just coming out right now, is that more than likely UIA and some aspect of DIA is actually going to be bound within your profile management service. So obviously, if you're using Microsoft roaming user profiles today, that's just not going to happen. Microsoft has no plans of updating or releasing anything to handle UIA or DIA. But there's a lot of other third-party companies out there that are. The one caveat that I'm going to ask you to question when you're presented with companies that actually implement UIA or DIA is, are you using a layering technology? And so what does that mean? Layering technologies are very, very similar to what SVS and ThinApp and AppV do, where they take the application and they abstract it. They stick it inside a shell or a bubble or anything else. And the problem with that take is while it works very well and lets you do cool stuff like stick IE6 inside Windows 7, the downside is you have to plan for everything that applications use to talk to each other. So plugins, interoperability, compatibility problems, these become really, really large when you're dealing with a layering level. If you have something that handles UIA on a native level, which unfortunately does not exist yet, but might exist in the next 6 weeks, I'm just saying. If you have something that handles things on a native level, that level of compatibility and functionality is no longer something you have to worry about. You can simply say, I'm going to stand up a non-persistent link clone image. I'm going to blacklist and whitelist my UIA to make sure that my users install what I want them to. And then DIA is going to be reserved for all my big applications. And then I can use ThinApp and SVS for all my really, really heavy-duty stuff that I need to bulldoze into my company, like Microsoft Office or IE6 on top of Windows 7 or anything like that. So ultimately, where we see UIA going is UIA and DIA are going to be gap fillers. It's going to allow corporations to very quickly and very easily realize the success of non-persistent link clones without changing your packages. Because UIA isn't just limited towards things that you download off the internet. It can also be things like WISE installation packages, MSIs, CDs that you've had stuck in the corner for the last 10 years. Anything that you can imagine can be implemented by a UIA and DIA. So just ask yourself the tough questions of, do we want to go down the layering road? And then once you start doing that, you'll see there's only a handful of vendors out there that can offer technology that does anything but.
Thanks, Matt. One last question here, and we probably should wrap up. Is there a way to calculate what an organization may need in terms of their supportive VDI environment without all of the manual math and heavy lifting?
Yes, Terakai. That's kind of the whole point, is that the only reason that we even know about all this math, aside from my mathematical errors about not having pluses in there, and again, I apologize about that, the only reason we know about this math is because we fell down. We landed flat on our face and we failed. Terakai has seen the best and the worst, and they've helped corporations who have already fallen pick themselves up, dust themselves off, and get themselves to where they need to be. The short answer to your question is use the partners and vendors who have done this before. No one likes math, except for mathematicians, and even then I'm not sure. The software that does this for us, the vendors who do this for us, are really the ultimate tool that you can possibly use.
Excellent. I'd like to thank all of you in the audience for your participation and insightful questions. I hope this webinar met your expectations. If you happen to have missed part 1 or part 2 in the series, please visit the Terakai website to watch streamed archived versions of each. Today's webinar will be archived in the next few days as well. Terakai will be hosting these regularly, and we'd love your input on topics. So please don't be shy. Let us know what you want to hear, what you want a little bit of a deeper dive in, and we'll do our best to accommodate. Thank you again, everyone, and have a good afternoon.